Life Under Ice by Mary M. Cerullo. Photography by Bill Kurtzinger. Since Antarctica was discovered in 1820, scientists and researchers have braved gale-force winds, mountainous waves, thick fog, and giant icebergs to study one of the few wild places left in our world. Antarctica is a land of extremes, the coldest, driest, windiest, and highest continent. Its name, Antarctica, means the opposite of the Arctic. 90% of the world's ice and 70% of the world's fresh water is frozen in Antarctic glaciers up to 2 miles thick. If they were broken up, there would be enough to supply every person on Earth with an ice cube as large as the Great Pyramid. In the winter, this continent at the bottom of the Earth doubles in size as sea ice spreads out from the coast for thousands of miles. On the surface, Antarctica is a frozen desert, but beneath the sea ice lies a strange oasis, home to an amazing variety of animals and plants that thrive in sub-freezing water, sheltered by the ice that covers their home like a glass roof. Nature photographer Bill Kurtzinger has traveled to this frozen continent many times to dive in its chilly waters and learn about creatures that are able to live in water that is as cold as it can get before you have to walk on it. His dives beneath the ice are adventures in science and survival. On this trip, Bill and a research team board a helicopter at McMurdo Station, the main center for scientists in Antarctica. The helicopter will drop them off 50 miles away near the edge of the frozen McMurdo Sound. Bill, Paul Dayton from the Scripps Institution of Oceanography, and 2 other dive partners are planning to study and photograph the animals that live on the bottom of the Southern Ocean, the Benthic Life. In this picture, this is an emperor penguin who watches new arrivals. And down here, the Weddell seal. This is the fur seal. The fur seal and the Weddell seal are 2 of Antarctica's marine mammals. And here's a picture of the fur seal. When you dive in Antarctica, you don't just tumble off the side of a boat, or you might end up with a concussion. First, you must drill through 5 to 10 feet of sea ice. In the past, underwater explorers used chainsaws and dynamite to create diving holes. Today, divers use machine-powered augers to drill neat, round tunnels. Bill and his team land near a breathing hole left by a Weddell seal. The seal had found a crack in the ice, and with its sharp, protruding teeth, it chiseled a hole to reach the surface to breathe. This makes the diver's first task easier. All they have to do is enlarge on the Weddell seal's work. To prepare for this dive, Bill wiggles into his dry suit, a well-insulated dive suit that doesn't allow water to get next to his skin like a regular wetsuit does. The dry suit covers all of his body except his face and hands. He pulls on insulated gloves that look like giant mittens. Then he slips on his flippers and mask and lifts his dive tank. He gives his dive companions a thumbs up to show that he is ready to go. As Bill drops down through the crack in the ice, he feels a little like Alice in Wonderland, falling down into the rabbit's hole. He can't help gasping at the cold water. His lips and cheeks, the only exposed parts of his body, go numb, and within a few seconds his head starts to ache from the cold. Even in summer, water temperatures average 29 degrees Fahrenheit to 35.4 degrees Fahrenheit. Why doesn't the ocean freeze? The water temperatures around Antarctica ranges from 28 degrees Fahrenheit to 35.4 degrees Fahrenheit. Fresh water freezes at 32 degrees Fahrenheit. Salt water freezes at a lower temperature because the dissolved salt blocks the water molecules from linking to form ice crystals. Seawater eventually freezes around 28 degrees Fahrenheit. It also melts at a lower temperature, which is why road crews salt icy roads in winter. In the ocean, the salt is left in the water during the freezing process. This makes Antarctic water saltier than most of the world's oceans. They are making this dive in October, which is early spring in Antarctica. The water is still as clear as a tropical sea, but by New Year's, when the sun is overhead 24 hours a day, billions of tiny floating plants called phytoplankton will be in full bloom. They form a thick sea soup, and Bill would barely be able to see his hand in front of his face. But now, after 6 months of darkness, May through August, there isn't enough plankton to block Bill's view, and he can clearly see the diving hole from several hundred feet away. The sun illuminates the open water of the hole like a spotlight. Bill and his dive partners take turn backs frequently to make sure the hole is still in sight. It's their only link to the world above. Should Bill lose track of the hole, he will retrace his route until his escape hatch is once more in view. Bill shivers not just from the cold, but as he imagines being trapped beneath a solid ceiling of ice. Winter or summer? When it's winter in the northern hemisphere, it is summer in Antarctica. Summer temperatures around the coast average a balmy 32 degrees Fahrenheit. Winter air temperatures hover around -60 degrees Fahrenheit. It's so cold that ice cream stored outside has to be microwaved before it can be eaten. Almost immediately, a Weddell seal spies Bill. Like an eager puppy, it dashes over to size him up. The curious seal moves in for a closer look until it is nose to nose with Bill's face mask. It circles the divers for a few minutes before swooping past them to poke its head through the dive hole for a quick breath. Then it plunges into deeper water. The divers also descend, but much more slowly than the seal. Within seconds, the seal returns from the depths to check them out again. Weddell seals can dive deep and then surface quickly because they don't get the bends like humans do. The bends, also called decompression sickness, are caused by nitrogen gas that becomes trapped in the blood. If a human diver returns to the surface too quickly, the change in pressure may release gas bubbles into the bloodstream that may burst and cause dizziness, paralysis, collapse, and even death. But as a Weddell seal dives, its rib cage partially collapses, squeezing air out of its lungs until it equalizes the pressure of the water above, keeping the dangerous gas bubbles from forming in its blood. Like whales, these seals store oxygen efficiently, and their blood is pumped away from their flippers to their heart, lungs, and brain, where it is needed most. Scientists have outfitted Weddell seals with instruments that record how deep they dive. They usually dive to 650 to 1,300 feet, but can descend to almost 2,000 feet in search of fish, squid, and bottom animals. They can hold their breath for over an hour. Bill stops a few feet above the ocean floor. It's a beautiful and haunting place, carpeted with sea anemones, sponges, sea stars, brittle stars, sea urchins, sea spiders, worms, and soft corals. It's as colorful as diving on a coral reef in the tropics, and Bill almost forgets how cold he is. As they swim along, Bill and his diving team are careful not to cause damage with their long flippers. Out of the corner of his eye, Bill sees a chunk of ocean floor drifting slowly upward toward the surface. Unfolding before him is the answer to a mystery that used to puzzle scientists. Every so often, someone would find a starfish or a sponge sitting on the surface of the sea ice. Since these bottom dwellers can't swim, how did they get there? Scientists love to find the answer to a mystery. By careful observation, they discovered that every spring, fresh water from melting ice pours off the land and the surface ice and sinks to the bottom of the ocean. Slightly colder than the surrounding salty water, this anchor ice freezes as soon as it touches a rock, mud, or an unlucky animal lying on the ocean bottom. As the bits of anchor ice gradually merge, it becomes more buoyant and floats up, carrying sea stars, sponges, and an occasional slow-moving fish up through the water until they bump into the surface ice and freeze into the underside of the ice. Gradually, the ice above melts away, exposing the sea stars and other creatures that would normally be living on the ocean floor. Bill's diving team follows a slope down to a depth of about 120 feet. It's like taking a slow elevator down a 12-story building. Paul is a benthic ecologist who is diving today to learn more about sponge growth in Antarctic waters. He finds a giant sponge larger than himself, and while he measures it, Bill swims around him, capturing shots of his work. Paul is careful not to push too hard on the sponge for fear of damaging its delicate structure. After about a half hour, Bill's hands and feet have grown numb. His fingers are so stiff he can no longer adjust the focus on his camera, so he signals his partners that it's time to go up. They rise up to a depth of 30 feet, where they stop and allow their bodies to decompress for several minutes. Returning to their dive hole in the ice takes longer than they expect, because distances in crystal clear water seem much closer than they really are. Diving in cold water uses much more energy than diving in warmer seas, and the divers rise to the surface completely exhausted. Bill and the others crawl into a tent and crank up a kerosene stove to get warm. They are going to spend 3 nights in the tent, so they can make several more dives before returning to the science station. Each member of the team devours a stack of steaks, then settles into his or her thick down sleeping bag. Before turning off his headlamp, Bill writes down his thoughts and makes some quick sketches of the strange animals he has seen. He has a lot of questions to ask the scientists back at the science station, and is looking forward to hearing their explanations and ideas. Bill falls asleep soon, but he tosses and turns all night and never really warms up. His dreams are jumbled with images of ice and snow. He wakes up before 6 a.m. The sun is still as bright as it was when they went to bed, but it's freezing cold in the tent. The condensation from their breath has formed a coating of rime ice inside the tent. Their toothpaste is frozen solid. The bravest one climbs out of his sleeping bag to start the stove. Soon the temperature inside the tent is bearable and coffee is made. Getting ready for another dive, Bill reminds himself that the water under the ice will be warmer than the air above. Bill and the dive team spend 4 days out on the sea ice before the helicopter comes to take them back to McMurdo Station. After a long hot shower and a huge meal at headquarters, Bill pulls out his journal and peppers the scientists sitting around the table with his questions. A geologist, a marine biologist, a meteorologist, a physical oceanographer, an astronomer, and even a veterinarian are all working on various projects at the science station. Bill has dived in all the seas of the world, but diving in Antarctica will still amaze him. Nowhere else do marine animals face the challenges they have to contend with under the ice. Here they have to swim in water cold enough to freeze their blood. It is dark for 6 months of the year, and without sunlight to fuel plankton growth, plant eaters have no food. Bottom animals risk becoming trapped to anchor ice. Air-breathing seals have to find holes just to breathe. Penguins sometimes commute hundreds of miles between their nesting sites and the sea to find food for their chicks. Bill asks the scientists around the table, "Why do the animals put up with the cold and ice?" The researchers digging into the plate of freshly baked cookies respond to a chorus. "Food! The Southern Ocean is like a giant food factory," they explain to Bill between bites. "Strong currents act like a spoon in a pot, stirring up a thick soup of nutrients. Minerals from melting glaciers mix with decaying plants and animals from the ocean floor, and when you add abundant sunlight, you have ideal conditions for an underwater greenhouse. Tiny plants called ice algae grow in pockets on the underside of sea ice, and phytoplankton, microscopic floating plants, bloom in the water near the surface. These are eaten by shrimp-like creatures called krill. Each krill is only the size of a human thumb, but when there are thousands of them together, they can turn the ocean pink. There isn't much variety to eat in Antarctica. The food web is simple, so krill are very important. Penguins, squid, fish, seals, seabirds, and even enormous whales all eat a steady diet of krill. Bill has spotted several kinds of whales swimming in the open water surrounding the Antarctic continent, well insulated from the cold by thick layers of blubber. Killer whales, minks, humpbacks, finbacks, and even the giant blue whales feast on the krill. In fact, the word krill is the Norwegian term for whale food. Bill doodles a picture of a krill on his napkin, which prompts him to recall the sketches he made in his notebook of an animal on the ocean floor that he couldn't identify. He turns to Paul Dayton, sitting at the far end of the table, and asks, "What was that huge, prehistoric-looking bug? It seemed familiar, but I've never seen one so big. It looked like something you'd seen at an Age of Dinosaurs